here it is for part B of this question. So I went on and graphed it, and you see how they're pretty similar. It's just a matter of the slopes here. And these arise because, think about it. If we have this one right here, x prime is equal to x squared plus y squared minus 1. So the x slope is going to be the same. The y here increases twice as fast for the same amount of x. So the question that arises is, can we find a point where we can see what the slope should be? So let's say we find the point 1, 1. Let's look at the point 1, 1. So here's 1 and here's 1. Look at this point right here. If I substitute 1, 1 into the first one, I'm going to get what? So let's write it over here. So if I input case, well, it's not the case. Answer A, and it's going to be x prime should be equal to, well, if x is 1, squared is just going to be 1, plus y squared is going to be 1, so 2 minus 1, that's 1. Y prime is equal to 2 times 1 times 1, so that's 2. So I can say that the slope, if we assume that these are both with respect to time, then we can say that the slope, y prime over x prime, is equal to dy dt dx dt, where the dt's would cancel out if we treat them unofficially as a algebraic quantity. So what we get is that for 1 in the x, I'm going to move 2 in the y. So this would be a 1 and this would be a 2. And my arrows should be pointing in this direction. Now they don't. So that makes us think that it's the third one. And let's try to confirm this with answer C. X prime is going to be the same because they're the same, but this is going to be just 1. So 1, that's going to be here and here. It's going to be a single square. So this is more in line with the arrows. So now we can say with confidence that this is our answer. But it was still useful to show you how to check, how to find the Jacobian and put the points in and see if we could exclude them this way. But the way they wrote them, and we should have known because if you look at the form is pretty similar. The way they wrote these, turned out to be a little bit trickier. Anyway, and a phase plot, this is what this is called, is particularly useful when you find y as a function of x, knowing that both of them are autonomous with respect to t, with respect to time. All right, well, I hope this was useful, and I'll see you next time.